All right, let's talk about how to find probabilities for an X bar distribution or a sampling distribution for X bar. So there are some things that we need to discuss before we can actually start calculating probabilities. We need to figure out if the sampling distribution is normal. We do this using the central limit theorem. And so the central limit theorem tells us that if your sample size is large enough, the X-bar distribution will appear normal. And again, in intro stats classes, we use n greater than or equal to 30 as the cutoff point. And so in this example, we're told that the mean gas mileage of a new car is 27 miles per gallon, and the standard deviation is 3 miles per gallon. And a company is buying 60 of these cars. And so since they're buying 60, this is the sample size. So n is equal to 60, which is greater than 30. So yes, the X-bar distribution is approximately normal. And so let's write out all of the variables that were given. And let's put it pretty organized because we're going to need all of these variables coming up for these next few examples. And so we're told some things about the population. And so for the population, we know that the mean is 27. So mu is equal to 27, while sigma is equal to 3. And then at some point, we're going to need the information for the X-bar distribution when n is equal to 60. And so here, you're going to have mu sub X bar, which is equal to 27 because it's just equal to mu, right? And remember, this is because mu is the expected value. And so whenever you're taking a sampling distribution, you would expect the mean of that sampling distribution to be your population mean. Okay, so the next variable that we're going to need is sigma sub X bar, so the standard deviation for samples of size 60. And here, this is always equal to sigma divided by the square root of n. And so you're going to have 3 divided by the square root of 60. And this is going to give you 0.3873. And so remember, the more numbers or the more decimal places that you round to, the more accurate your results will be. And so let's move on to the next part of the example now. Part B is asking us to find the probability that the average mileage of the fleet is greater than 26.5. Because this is asking about the mileage or the average mileage of the entire fleet, we know we're looking for the probability that the sample mean is greater than 26.5. And then to find this probability, we can use the normal CDF function or the normal curve applet that I've used in previous videos. And so here, when you use the normal CDF function or when you use the normal curve applet, your minimum value is going to be this 26.5. And then because it's greater than, you make your maximum value something very large. And then for the mean and the standard deviation, that's going to depend on which variable was placed here. If this was x without the bar, so just a data value x, I would just have mu and sigma. But because I have x bar here, I'm going to be using mu sub x bar and sigma sub x bar. So you have to make sure that the values that you place here match the variable that you placed here, which means I'll have 27 and 0.3873. And so when you find this, you should get a value around 0.9016. Part C is now asking us to find the probability that the average mileage of one car chosen at random is less than 28 miles per gallon. And so what that means is we are being asked to find the probability that one data value from the population is going to be less than 28 miles per gallon. And so that means we're dealing with this first distribution that I listed up here. And so in my probability notation, that also means I'm just going to have x, because that's what we use to represent just one single data value. I want to find the probability that x is less than 28. And so when I use normal CDF, because I have less than, I'm going to make my minimum value something ridiculously small. My maximum value is going to be the value I'm given. And because I'm dealing with one single data value, I'm going to use just mu and sigma. And when you solve this, you should get 0.6306.